Hello everyone, this video is just an updated version of the last video which I had posted but removed due to some typing error in the video which was reported by a student only. Yes, so in this video with that error corrected, now let us start this video. And the first question is on your screen. The first question is really very powerful question. Uh, this question is going to teach you so many concepts at the same time. In just one question you are going to learn so many concepts. Let's see. Question says let f of b is the maximum value of mod of sin x minus 2 divided by 2 plus sin x plus b, where b is also a real number, x is a real number. We have to find the minimum value of f of b. That is, we have to find the minimum value of the all the possible value of the maximums. So suppose that sin x is equal to t. Since this question, solving this question in the variable x is really very difficult, so we have to simplify this question in terms of some other variable. So as you can see, so I have assumed that sin x is equal to 2t. Since sin x lies between -1 and 1, therefore t lies between -1 and 1, and my expression becomes t minus 2 divided by 2 plus t plus b, mod of that. Now let us say that g of t is equal to t minus 2 by 2 plus t plus b, where t lies between -1 and 1. So to find the maxima of mod g of t, let us first find the maxima and minimum of g of t. For that, I am differentiating the function g of t, and I am getting g dash t is equal to 1 plus 2 divided by 2 plus t whole square, where t lies between -1 and 1. And as you can see it very easily that g dash t is positive. Since positive plus positive terms are positive, so therefore g dash t is greater than 0 for all t belongs to one interval -1 and 1. And therefore g of t is increasing function. As you know from the monotonicity of function, g of t is an increasing function for all t belongs to -1 and 1. Okay, so now maximum value of g of t. Since g of t is a strictly increasing function, so maximum value shall be achieved at the right end point. So maximum value of g of t is equal to g of 1. Now putting t is equal to 1 in the expression of g of t, we are getting maximum value of g of t as 1 by 3 plus b. Similarly, minimum value of g of t is obtained at g of -1, and that is equal to, as you can see, you can put t is equal to -1 and you're getting -3 plus b is same as b minus 3. But since f of b is actually, it is the maximum of mod of g of t, it is not the maximum of g of t, rather it is the maximum of mod of g of t. So therefore f of b, as you can see from here, t lies between -1. So as we know the maxima of g of t and minima of g of t, so there can be two possibilities magnitude wise. Either the magnitude of maxima shall be greater than the magnitude of minima, or the magnitude of minima shall be greater than the magnitude of maxima. So let us suppose the first case, in which the magnitude of maxima is less than the magnitude of minima. As you can see, the maxima is attained at t equal to 1 and minima at t equal to -1. Now if I draw, since the above graph, the upper graph is of g of t, if I draw mod g of t, considering this is g of t, then mod g of t shall be like this. As you know, the negative portion is reflected with respect to t-axis, and therefore in this case, since the f of b is the maximum of g of t, as you can see that it is equal to the mod of g of -1, and which is equal to, since g of -1 is b minus 3, so mod of b minus 3. So in this case, if this is the situation as I have considered in case 1, then f of b is mod of b minus 3. Similarly, case 2 can be in a case where the magnitude of the maxima is greater than the magnitude of the minimum. As you can see here, maxima is obtained at t equal to 1. So therefore, considering this graph of g of t, if I draw the mod g of t, it will be something like this, as you can see here. So this will be the graph of mod of g of t, and upper graph is of g of t only. So in this case, since f of b is the maximum of mod of g of t, so therefore f of b will be equal to mod of g of 1. As you can see, mod of g of 1, and g of 1 is 1 by 3 plus b, so mod of b plus 1 by 3. So depending on the situations, whether the case 1 or case 2, f of b can be maximum of the two cases. Either it can be mod of g of -1 or the mod of g of 1, depending on which value is more. And substituting the values, we are getting f of b is equal to maximum of mod of b minus 3 and mod of b plus 1 by 3, right? So for finding the minimum value f of b, we must have to first draw the function f of b, as b is a variable. belongs to R, so B can be any value between minus infinity to infinity. So let us first draw the two curves, y equal to mod of b minus 3 and y equal to mod of b plus 3. I'm drawing the two curves. I'm drawing the first curve as that is mod of b minus 3, as you can see with yellow line, with the green line, sorry, and yellow with yellow line, mod of b plus 1 by 3. So this is actually 3 comma 0 and this is minus 1 by 3 comma 0. And since these two graphs, the green and the yellow graph, is intersecting at a point, as you can see clearly in the graph, so we also must find that point of intersection. So for that, let us solve the two equations, and this is 3 minus b is equal to b plus 1 by 3, and from here we are getting that 2b is equal to 8 by 3, and then b must be equal to 4 by 3. So this point is actually nothing but the corresponding point on the t-axis would be 4 by 3 comma 0, right? Okay, so now since we have to consider the maximum of the two graphs, so as you can see, for b less than 4 by 3, the green graph is the maximum, as I am drawing with the red line, and for t greater than 4 by 3, yellow line is the maximum. So this is actually the graph of f of b. Now other parts are redundant, so I am removing the other parts. So removing the other parts, we are getting this graph. Now, so since you have gotten the graph f of b, so from the graph itself, you can see that the minimum of f of b is occurring at at b equal to 4 by 3. So the minimum of f of b is equal to f of 4 by 3, and f of 4 by 3 is nothing but you just put b equal to 4 by 3 in any one of the expressions, since both expressions are meeting at 4 by 3. So therefore you are getting that the minimum of f of b as 5 by 3. Okay, so this is actually the solution of this question, and this is in fact a fantastic question to learn so many concepts at the same time. In just one question, in just one solution, you can learn so many concepts and you can apply these concepts. These concepts are very, very compulsory concepts, compulsory techniques actually, to solve the advanced question. You might encounter such question in very advanced, because this question involves more sort of common sense, more sort of applying the concepts that you learn in your classroom program. And I hope that you have liked this solution, and at least you have understood this solution, you have learned the concept, and you shall be able to apply this concept in any question that you might face similar to this question. Let us move on to the next question. Next question is from permutation and combination. The question says that suppose we have to distribute 10 identical red balls and 10 identical green balls uh, equally among 5 children, right? So we have to distribute 10 identical red balls and 10 identical green balls equally among 5 children. So each children should get exactly 4 balls. In how many ways this can be done? Okay, so we have to think about the algorithm. Suppose in real life, if you were given this task, how do you do? So what I would do, that I would just first distribute 10 identical red balls in all possible ways. Just I would take care of one thing, that no child is getting more than 4 ball. And in that case, suppose if some child is getting less than 4 ball, then I would compensate that child with green balls. So this is my idea of solving this question. So I am going to distribute the 10 identical red balls among 5 children, and such that no child is getting more than 4 balls. Suppose that ith child is getting xi number of balls, right? So suppose first child is getting x1 number of balls, second child is getting x2 number of balls, and so on. So suppose that ith child is getting xi number of balls, and of course xi should lie between 0 and 4, because no child should have gotten more than 4 balls, since each child must get exactly 4 balls at the end of the distribution. So I'm assuming this. So I'm going to apply the multinomial theorem, as you must have studied in your permutation combination chapter, the application of multinomial theorem in finding the number of number of ways of distributing identical objects. So this is x1 plus x2 plus x3 plus x4 plus x5 is equal to 10, and using multinomial theorem, number of ways of doing this is equal to coefficient of x to the power 10. In the expansion of, actually, as you can see that x1 varies from 0 to 4, x2 varies from 0 to 4, so x to the power 0 plus x to the power 1 and up to x to the power 4, and since there are 5 cases, so multiplied by 5 times, so raised to the power 5. That is equal to coefficient of x to the power 10 in doing this GP series summation, and we are getting 1 minus x to the power 5 divided by 1 minus x raised to the power 5. So now I'm just going to express this expression in different way. I'm writing coefficient of x to the power 10 in 1 minus x to the power 5 raised to the power 5 into 1 minus x to the power minus 5. And using binomial theorem, if you expand 1 minus x to the power 5 whole to the power 5, then this is equal to coefficient of x to the power 10 in, as you know, 5c0 is 1, so 1 minus 5c1 is 5 into x to the power 5 plus 5c2 into x to the power 10. And I'm ignoring the higher terms containing power of x because we don't have to consider them. They are not going to produce any coefficient of x to the power 10. So this is equal to coefficient of x to the power 10 in, if you multiply term by term, 1 minus x to the power minus 5 into x to the power 5, 1 minus x to the power minus 5, and 5c2 is 10, so 10 into x to the power 10 into 1 minus x to the power minus 5, and ignoring the other terms because that is not going to contribute in the coefficient of x to the power 10. So that is equal to coefficient. Now you must be knowing this formula, coefficient of x to the power r in the expansion of 1 minus x to the power minus n, right? And this is equal to n plus r minus 1 cr. Okay, so I'm going to use this formula. So from the first term, the coefficient of x to the power 10 is equal to, as you can see, this is equal to 5 plus 10 minus 1 c10. From the second term, we have to get only x to the power 5 because x to the power 5 is already there, so 5 plus 5 minus 1 c5. And from the third term, x to the power 10 is already in the coefficient, so I'm getting just constant term, that is 10, and that is equal to 14 c10 minus 5 times 9c5 plus 10. So this is the number of ways of distributing 10 identical red balls among children, so that no child is getting more than 4 balls. Now suppose that some children must have gotten less than 4 balls, right? Since I've just taken care of the maximum number of balls, I've not taken care of the minimum number of balls. Let us distribute the green balls in such a way that after distributing the green balls, each child must have 4 balls exactly, right? So each child should get exactly 4 balls in total at the end of the whole distribution. So suppose that some child have gotten only 2 balls, so let us give him 2 balls. Some child has gotten 3 balls, so let us give him 1 ball. Some child have gotten no balls, so let us give him 4 balls. And doing all this, is there is only one way to do this, because number of ways of choosing are objects out of n identical objects. See here, identical what? So n identical objects is equal to 1, because if you have to choose 2 ball out of 10 identical balls, number of ways is 1. If you have to choose 4 ball out of 10 identical ball, number of ways is equal to 1. So we actually have to compensate the children who are falling short of 4 balls by giving them green balls. So total number of ways of distributing red balls as well as green balls is equal to total number of ways of distributing red balls as well, and total number of ways of distributing green balls. So total number of ways of distributing red ball is this, and multiplied by 1. So this is actually the final answer. I hope you have liked this video. You must have learned so many concepts from this video that are very, very useful. Okay, bye everyone, take care.